Hello and good morning. So yesterday my topic was, what was my topic? Yesterday my topic was what is a virus, and today we have got a lockdown in our place, and I had to go to a very important survey work for my research, but we couldn't do it because it suddenly closed. If it had closed one day later, then we would have done it, but no, it wasn't. This time it wasn't there to be. So today my topic is habitability of exoplanets. So we know what our exoplanets are. Planets, those that are outside our solar system, are called exoplanets. Exo means outside. And habitable exoplanets are those who are supposed to have life like what we have here on Earth. And the zone of habitability of those kind of planets lies in a place where liquid water can exist. And for liquid water to exist, the temperature of the place should be around, minus 50 degrees to plus 50 or 100 degrees. And there can be varying amounts of pressure and other atmospheric conditions. So while it does not say whether life will exist in exoplanets in the habitable zone, or whether there cannot be other forms of life, they do not say that, but say that the probability of life like Earth happens only within the zone of the exoplanets. And the nearest exoplanet which is in the zone of habitability is one called Gliese, and it might be pronounced differently in different places. And this Gliese is a size which is between the Earth and Jupiter, and it is detected very recently in the 2000s and 2010s. It was disputed, and it's still disputed about whether it really exists, because they're very, very far off, and when they're that far off, it is very hard to observe them directly, and they are observed by a process known as the dimming of stars, which happens when the planet comes in near the orbit in front of us, and the planet is between the star we are looking at, the sun at that location, at that star, ourselves, and in between we have the planet. And when the planet comes to this point, the light from that star dwindles, and we can calculate the possibility of having a planet there. And there are other such ways to measure indirectly the existence of exoplanets, but this is one of the most basic ones. And this Gliese is a candidate for extraterrestrial life. And in our solar system, we do have a few candidates, which include Ganymede, Europa. Once we tried to include Mars in that, but now we think it is very unlikely life currently lives on Mars. But still, we can find life in these moons of Jupiter, the moons of Saturn, moons of Uranus, and moons of Neptune. And I hope within the next 50 years, we will have probes going there. We already have probes going there, but we hope that probes will go there and put much more research into whether extraterrestrial life lives there. And although they are a bit far off from the habitable zone, their life can still exist in between, in subsurface oceans, such as in planets like Ganymede, or also in parts of the atmosphere where it is less dense, where it is more habitable to life. So that's all for today. Thank you very much, and hope to see you again on day 4.